Okay, so the cotangent is 7 pi over 6. Pi is 180 divided by 6 is 30 times 7 is 210. So we have the cotangent of 210. Now, when you draw 210 degrees in standard position, doesn't it end up down here? So there's my butterfly bow tie. This is 210 degrees. And then the reference angle right here, okay, this was 210. This is 180. So this angle must be 30. So we got a 30, 60, 90 there. And across from the 30 is 1 and root 3 and 2. And then, of course, we got to put on the brakes, which you all did, or many of you did. And you said, oh, I got negatives in here. You do. In fact, aren't both of these negative? So what happens when you do the tangent or the cotangent? Since they're both negative, you should end up with a positive answer, right? And a lot of you had negatives here, so I just wanted you to make sure. You had the right number. You had root 3 because it's adjacent over opposite. It's root 3 over 1. But you had a negative on it. And in this quadrant, since they're both negative, the tangent and cotangent will be positive. Will everyone agree with that? Okay, all right. All right, let's get our notes out. We're going to sketch one period and label in radians. Now, at the beginning of the year, we had our BFFs. And included in the BFFs were the sine and the cosine. Remember? So we had two shapes. This is A and B. So I'm going to do A and B together here because we've already sketched these two, but not as precisely as we're going to do now. So the sine, remember, started at the origin. Remember, original sin, origin sine. And you drew a hill, and you drew a valley, and that is exactly what you're still going to draw. What that hill and valley represents, though, is one trip around our circle. So in other words, one trip of angles, one set of angles in a revolution. This represents a revolution. So in radians, if this picture represents a revolution, then what will this end label be? What is a revolution in radians? 2 pi. So once around is 2 pi. So this picture represents one revolution. So it's 2 pi, which means the middle piece here will be pi. And the top of the hill here, which is the middle of the hill, will be pi over 2. And then the bottom of the valley here is 3 pi over 2. 1.5 pi or 3 pi over 2. In degrees, this would be 90, 180, 270, 360. So see what I mean? It's a trip around the circle. This represents quadrant 1, quadrant 2, quadrant 3, quadrant 4. One trip around the circle. The height of these waves, we haven't really spent much time talking about this, but the height of those curves is 1. And here is why. If you think about the value of the sine, opposite over hypotenuse, when you build that fraction, opposite over hypotenuse, won't this always be bigger? So this fraction is never going to be bigger than 1. Because if it were going to be, like if it were going to be 5 over 4, that would mean the opposite side is longer than the hypotenuse, and that can't happen, right? So the top, the highest value of your sine is 1, always, the sine will never be more than 1, or, excuse me, less than -1. The distance from the beginning to the end of the picture, and I have to be careful because I'm saying beginning and end, but these really go on forever because couldn't I keep going around the circle? But every trip around the circle is going to produce a picture that looks exactly like this. Would you agree with me? Sure. So we don't generally draw that extra part because it's going to look exactly like this part. There's no difference. And back here too. So one trip around this hill and valley is called a period. Have we used that word before? Back in, remember, didn't we talk about amplitude and period back in chapter 1 when we were looking at those weird shapes that looked like this? Remember things like this? This distance right here, we call the period. Maybe I didn't use that word because they weren't repeating. But anyway, that's the period. So the period of the sine curve is 2 pi. One time around, one loop. Anything extra I draw will be repeat. Okay? So one original piece is the period. And then the amplitude, which is the height of the curves, is 1. The amplitude is the height of the curve, the height of the waves, the height of the hill, depth of the valley, and that is 1. This, gang, is the basic sine curve. Now, if you look down through the page, you see we're going to be sticking some things into it. But this is the beginning. This is what we start with. Same, I don't know why I wrote cotangent. Same thing with the sine, or cosine. Only remember, the cosine starts up above and does this. It, too, goes on and on and on forever, but we only graph one trip around the circle. So here's 0, and here is 2 pi. One trip around the circle. That's what it looks like. So the middle of this curve is down here. So this is pi over 2, and 3 pi over 2. One trip around the circle, 0 to 90, to 180, to 270, to 360. One trip around the circle. Its period and amplitude are exactly the same. When we were discussing the BFFs, we said the sine and cosine are the same curve. The only thing that's different about them is where they start. Okay, those are the basic sine and cosine. Now, we're going to make some modifications to them now. So let's look at problem C. This is what we're starting with. And in fact, I think I'll just leave it there for a minute. That's what we're starting with. And now I'm going to graph 2 sonnets. Anybody remember what a number out in front of the function does? Multiplies the y. Yay, good job. Multiplies the y. So in other words, instead of the hills going up up one, now they're going to go up 2. So I'm going to have exactly the same shape. But now, my amplitude is going to be 2. So I still start here, go up, and I still cross here, and down, and there it is. It is exactly the same picture. Its period is still 2 pi, but its amplitude is now 2. All right, -3 cosine. Okay. All right. -3 cosine. What does the negative do? Flips it upside down. That negative out in front flips me upside down. So remember, your cosine normally starts up here, right? It's flipped upside down, so it's going to start down here. It's going to come up like this, and it's going to come back down. Now, I know that's a very weird shape, but remember, it's part of a continuing curve. So when I draw it in with the pieces continuing, do you kind of see the shape there? Okay, this is the starting point, that's 0. And this is the ending point, right here. This is the ending point, and that's 2 pi. Here's pi. Here's pi over 2. Here's 3 pi over 2. Now, what's my amplitude? -3 out here. What does that 3 do? Multiplies the height. So these labels are going to be 3 and -3. So you have to fill in your period and amplitude. Your period's 2 pi, and your amplitude is 3. Now, remember the amplitude is the height. So even though there's a negative out here, don't say the amplitude's -3. The amplitude will always be positive. Period and amplitude are distances, so they're always positive. The negative just tips you upside down. Is that okay? Oh, it's exciting stuff. Oh, now look at E. Okay. What's going to happen with E? Does anyone remember what the 2 on the X does? So we have 2 sine 2x. Does anybody remember what this 2 does? We already talked about that one. What does that one do? Actually, it does have to do with the period, with the horizontal of the picture, but remember this number divides the period. It divides the horizontal. It looks like it's multiplying, but it's not. It's dividing. So what does that mean? Well, let me draw my sine curve. It's a positive sine, so it has that shape, right? I know my amplitude's 2, so it's going up 2 and down 2 because of this. Now, a normal sine stops where? 2 pi. It's been halved. So I'm going to take all of my normal numbers and I'm going to cut them all in half. So instead of having pi over 2, these are my normal numbers. These are the normals. But this is dividing them all by 2, or multiplying them by a half. So what will this new one be? 1 over 4. And pi over 2? What will this one be? Multiply by half. 3/4 pi. And this will be just plain old pi. A number in this position divides the horizontal. It divides the period. So my period is now pi, and my amplitude is 2. The rules have not changed from back earlier this year when we did stuff like this. Don't you remember doing things like this where I do some random weird shape? You're doing exactly the same thing we did before, only now we're using this shape. Okay, what do we have next? Oh boy. All right, tell me about this. Look at it, think about what we learned before, and what do you think's going on with 3 sine 2x minus pi over 4? What do you think's happening? Well, we know what this does. What does that mean? 3 times as tall. Okay. We know what this does. This divides the period, right? So I can tell already my amplitude is going to be 3 and my period is going to be pi. 2 pi over 2.
It was one of those rare spots where the quality of the term really shines.
The period of a sine always starts out 2 pi. Then this will change it. Now, what about that? It's a subtraction on the x. What does that do to my picture? It moves it right. In trigonometry, that is called a phase shift. It's a horizontal shift. It's called a phase shift. And your phase shift is pi over 4. And I'll say positive because that means right. You could actually write R-I-G-H-T, pi over 4 if you wanted to. The positive always means right. So now what does that mean in terms of the picture? Well, that means that you're still going to have your sine curve. You're going to have that shape. But it isn't going to start at the origin because the whole thing has been picked up and moved to the right pi over 4. So I'm going to have my sine curve. Its amplitude is 3. Now here comes the part you gotta think for a minute. We have figured out that the period is pi. That means that from here to here is pi. This is not pi. It would have been pi before I moved it, but I've moved it now. You get it? Don't put pi here. This distance is pi. So how do I figure out what that is? Have you figured out what it is? What do you think it is? I heard someone say something, but I couldn't hear because he has a very deep voice. 1 1/4 pi? Absolutely. Only, Rory, I'm going to write that as 5 pi over 4. But it is 1 1/4, 5/4. So Rory said, okay, I'm starting at 1/4. I'm traveling 1. So I'm going to end up at 1 1/4. That makes perfect good sense to me. Now, this number is not the period. The period is pi. You already figured that out. So we had to take 1/4 and add a pi to it, and that's how we got 5/4. Now, this is going to be right in the middle. Right in the middle of 1/4 and 5/4. I know there's a pi on it, but I'm not using the pi in my calculation. What is right in the middle of 1/4 and 5/4? 3/4. What's in the middle of 1 and 5, right? 3/4. So this is 3 pi over 4. Now what's right in the middle of 1/4 and 3/4? 2/4. And I'm not going to count off if you don't reduce that. That certainly does reduce to pi over 2, but you've got a lot going on in these problems. So if you leave it unreduced, I'm fine with that. 3 and 5, what's in the middle there? 4/4, which would actually just be plain old pi if you reduced it. So on that one, you will be asked to list, I'm talking about like in the future on a test or quiz, the amplitude, the period, and the phase shift. Everybody okay with those numbers? 3 pi and pi over 4. And then you'll have to graph it. Whew, that's a lot.
So I have a question. What's the negative for that in the middle? Like what that's connected to? Does that have any significance?
The negative 4. You mean this minus? Okay, that's a minus. Whenever you add or subtract to x, you move left and right. So a minus moves you right,
Oh, okay.
because it's in the parentheses. If we put it on the end of the problem, it would be a vertical shift. It would take your picture and lift it up. All right. So now we're ready for G. Oh my, what a big problem this looks like. All right. One step at a time. Let's see if we can get through it. Tell me what you know by looking at the equation. What do we know about our cosine curve? Amplitude's 1/5. So when I draw, I'm going to just make a list here. The amplitude's 1/5. So when I draw, whatever I end up drawing here, I'm going to go up a fifth and down a fifth. Now notice I'm not really scaling this. Like 1/5 to negative 1/5, it would be really squished up. So I'm spreading it out so I can see it better, but I'm labeling. I always got to make sure I label. All right, what else do I know about it? Negative pi over 8 or left pi over 8. So my phase shift is negative pi over 8, or you can use the word left pi over 8, but that would go left, right? So I have a cosine curve that starts at negative pi over 8. Now remember, with a cosine, it starts at the top of the peak, right? Normally. So I'm going to draw this thing. There it is. There's my cosine curve. Maybe it ends somewhere. I can't figure out where it ends unless I know its period. What's the period of this thing? What? 4 pi. Absolutely. How did we get 4 pi? He remembered that this number divides the period. So the normal period is 2 pi, always and forever for a sine and cosine. 2 pi is a starting point. So we're taking 2 pi and dividing it by a half, which is the same as timesing it by 2. So that means that from this point to this point is 4 pi. Now, little hint, I'm going to help you. Since this is an 8, instead of thinking about this as 4 pi, I might think about it as 32 eighths. That's 32 eighths. And I know that I have to start here and travel 32 eighths to get here. So what will this label be? If I start at negative 1 and travel 32, where will I be? 31 eighths. That's it exactly, 31 pi over 8. You're starting at negative, this is negative 1 eighth. You're starting at negative 1 and traveling 32. So that's going to be your endpoint. Now what's going to be right in the middle of negative 1 and 31? Remember, to find the midpoint, you average. So negative 1 plus 31 divided by 2, that's going to be my midpoint. 15 over 8. 15 pi over 8. Yep, we're going to finish this picture. Now I need the midpoint here and here. I need both of them. So 15 and 31, what does that make? 15 and 31 makes 46. Divided by 2, this one's 23 pi over 8. And negative 1 and 15. this one's 7 pi over 8. Read.
How do you, where do you get like 3 pi?
I just got a common denominator, 4. You told me 4. Another way of writing 4 is to do 2 over 8, so that it matches that denominator.
You just add it to
Yep.
3 pi over 8.
Yep. Yep. Okay, well, we didn't get too many of them done, but we got some of them done. All right, so we'll finish up graphing tomorrow, or not finish up, but we'll continue that. All right. Okay, we're done for the day. We'll see you guys. Have a good day. All right, let's spray the desks.